Hello and welcome back. This video will be on the third section of the prerequisites chapter, which is all about square roots. And so first we'll look at this fairly simple equation, x squared is equal to 9. And when we're looking at this, we can see that if we are going to square x, as in multiply x times x to get 9, we know that 3 times 3 is 9, but we also know that negative 3 times negative 3 is 9. The negative signs will cancel out and give us 9. This is referred to as the square root. Here we call this x squared. So the root of this equation is going to be essentially the solution. And one square root is going to be 3, and another square root is going to be negative 3. However, generally we like the positive numbers a little bit better. So when I write this symbol, the usual square root symbol, what we are referring to is going to be the positive or the non-negative square root. So here, if I take 9 and I take the square root of 9, what I mean here is the positive square root of 9, not the negative one. And this has a name. So if we try to take the square root of a number that's not negative, the square root firstly exists, and there will be a positive and negative square root. The positive one is called the principal square root. Principal meaning the most important one, essentially in this instance. So, for example, 64, is a square number, and it's 8 times 8. So the principal square root of 64 is going to be 8. Whereas for 25, the principal square root is going to be 5. Now this just doesn't mean that we can't talk about negatives here. I just have to add the negative sign outside of it. So negative of the principal square root of 25 is going to be negative 5. And this is how we'll refer to the non-principal square root. And in all these examples with 64 and 25, we're talking about perfect squares. And a perfect square is just a number that essentially has a square root that is going to be rational. It's going to be a rational number. And they don't have to be integers either. So for instance, 1/4 is just going to be 1/2 times itself, 1/2 squared. So the principal square root of 1/4, for instance, is going to be 1/2. So we would call 1/4 a perfect square. Likewise, 100 over 49 is going to be 10/7 squared. 10 times 10 on top, and the 7 times the 7 on the bottom. So the principal square root of 149 will be 10/7. One thing to notice is that we're not taking the square root of any negative numbers. This is because square root of a negative number is not a real number. If you take any positive number, so for example 3, and you square it, we'll get another positive number. If we take a negative number and we square it, we still get a positive number. The smallest that we can get is if we square 0, we get 0. But you'll notice that you'll never get never get a negative number. These are all non-negative. So if you try to take the square root of a negative number, you won't get a real number, but we will discuss ways to talk about this in a later chapter. One thing to keep in mind is that the principal square root is always going to be the positive square root. So when I look at this, it's really tempting to want to say, oh, the square root of negative 4 squared should be negative 4. The square root and the square should cancel out. This is not correct. Why? If I include more steps, negative 4 squared is in fact 16 because the negative signs cancel out. And the square root of 16 is 4. So here, it's important to notice that negative the square root of negative 4 squared is in fact positive 4. When you take the principal square root of a number that has been squared, we always want to get a positive number. So we'll just take the absolute value. This is the easiest way to just make this be a positive number. It's good to keep this in mind. And now we'll look at how we can combine square roots here. So if I take the square root of 25 times the square root of 4, we know what both of these are. This will be 5 times 2, which is 10. But if I do this multiplication underneath the radical sign, 25 times 4 is 100. And we know that 10 times 10 is 100, so the principal square root of 100 is going to be 10. And what you'll notice is that we get the same thing. And this is not a coincidence. This will happen every time. So there's a rule for multiplying square roots, a product rule. So provided that we don't start with negative numbers, the square root, the principal square root of a times b is just the principal square root of a times the principal square root of b. And vice versa. We can combine square roots into one big square root. So we'll look more at this in just a second, but first I do want to mention when we consider a square root to be simplified. So we consider a square root to be simplified when it doesn't have any factors that are perfect squares. And the best way to go through this is to go through an example. Let's look at the square root of 200. 200 is not a perfect square. It is not a rational number times itself. So we'll have to simplify this a little bit. And when we look at this, we can go, okay, I know 25 is a perfect square, and 25 is a factor of 200. As in, 200 is going to be 25 times something else, which happens to be 8. And when I look at this, I can use what I had before to split this apart into two square roots. The square root of 25 times the square root of 8. This I can simplify a little bit. This is just going to be 5 times the square root of 8. And then from here, I look at 8 and I go, well, 8's not a perfect square, but it is divisible by 4, which is a perfect square. So I just keep going, and I keep breaking apart my what's called the radicand. The radicand is the part that's underneath the radical sign. So 8 here is my radicand, and I'll break that into 4 and 2. Split the radical apart into two of them, the square root of 4 times the square root of 2, and you'll notice that the square root of 4 is just 2. 5 times 2 times the square root of 2. And here I have run out. The square root of 2 can't be simplified anymore. So this is going to be 5 times 2, which is 10, times the square root of 2. This can be done in fewer steps. For instance, if we took this and broke it apart into 100 times 2, and then we could get to this step in one step. But any way that you can break it down will work. One example where we want to use some variables here is take the square root of 2 times z times the square root of 10 times z. So again, let's put everything under one big radical sign. So this is 2 times z times 10 times z. And we'll combine everything together and then start breaking it apart. So this will be the square root of, because we are multiplying and only multiplying, it doesn't matter the order in which we do this. So I'll take 2 times 10, which is 20. And I'll take z times z, which is z squared. And then from here, I can look at this and I can go, I see some perfect squares popping out of here. 20 is going to be the product of 4 and 5. And then lastly, I've got the square root of z squared. And this is pretty straightforward. The square root, the principal square root of 4 will be 2. 5 can't be factored anymore. It doesn't have any more perfect squares as factors. And the principal square root of z squared will be the absolute value of z. Now, just as an aside, if we come back and we look at this first radical, I've got the square root of 2 times z. The only way that I can take the square root of a number is if it's positive, which means z can't be negative. It could be 0, but it's at least as big as 0. Sorry, it can't be negative, but it could be at least as big as 0, which means when I take the absolute value of a number that's greater than or equal to 0, it's itself, and I don't have to include the absolute value signs anymore. The last thing that I'll mention here is the fact that because division is the same thing as multiplication by the reciprocal, there's another quotient rule. So here, the square root of a divided by b is going to be the square root of a divided by the square root of b, and likewise, the square root of a divided by the square root of b, I can just take one giant square root. So if we simplify this really quick, the square root of 10 times z cubed divided by the square root of 5 times z. Again, we'll just put everything under one big radical sign. 10 z squared over 5z. And here, we'll break this apart just a little bit so that it's easier to see. So 10 divided by 5 and z cubed divided by z. Using what we learned last time, we'll see that 10 divided by 5 is just 2, and z cubed, z to the third power, divided by z to the first power, is going to be z to the 3 minus 1 power, which is just going to be z squared. And then just like we saw before, z squared, I can break this apart, and the square root of z squared is just going to be z, and what we're left with is 1 square root of 2 at the end. And I'll continue talking about square roots in the next video.